Welcome back for part two of my experience with the Hynade PLC-50DP Pilot Arc Plasma Cutter from Amazon. I gave $199 for this unit, and let's see, if you saw part one, you saw my initial reviews and my first tryings to use of this thing. Here you can see I modified my welding cart. That's got my little MIG on it, and I stuck the plasma down the bottom of it. It works, fits pretty well. It'd be nice for it to be a little bit higher, but you know, I figure I'm not going to change the settings on that plasma very often. Honestly, I'm probably not going to use it very often. So down there in the bottom, so far seems to work just fine for me. I've added a couple of places here to hang the extra cables and all that stuff from both machines, and it works out, keeps it compact and portable for me. I've got the machine up here on the bench now where we can take a little better look at it. Show you some modifications that I have made to it so far. I've not really used it a whole lot, but where I've got it down in that cart, I found it easier to put a short leader hose for my air supply. Just makes it a lot easier than trying to bend down on my knees and try to hook up right next to the regulator. And I was a little bit worried about the pressure, you know, plugging a quick connect onto the regulator and you know, getting it back off. You know, I was worried about my regulator and the mounting of it, so this leader hose kind of takes care of that. You see the hose here where it feeds the air out of the regulator and into the machine. The machine came with a really long piece of that hose. Here it is. So you kind of have to cut it to length. This is how much I had left over. Why they give you that much hose, I really don't have any idea. You really only need about a foot of it there is all you really need. So this goes in the scrap bin, I guess, for use some other time. Let's see, the power supply. I couldn't find anything in the instructions or on the machine itself that tells you what the power supply requirement is, where you plug the power into the wall, either for 110 volt or for 220. I asked Hynade on Amazon, you know, what is the power requirement? It's funny, they came back and said at 110 volts, you needed a 30 amp breaker, and at 220 volts, you needed a 20 amp breaker. Well, that's funny because the plug that it comes with is just your standard 15 amp type of a plug-in. You have the two parallel prongs and the ground. Even a 20 amp 110 volt socket or a receptacle. The 15 amp has the two prongs, you know, straight parallel to each other like we're used to seeing, but the 20 amp, one of these prongs is actually horizontal. So you have one this way and then the other one this way. That's your 20 amp receptacles. So if your receptacle does not have that extra little horizontal plug in it, I've got one right here, like my receptacle there, that extra little horizontal place in it means that's a 20 amp receptacle. It's rated for 20 amps. So it's funny because they say, you know, 30 amps at 110, well, that's not a 30 amp plug. So in my shop here, I wired all my receptacles for 20 amp. My MIG welder seems to do just fine on 20 amp. If you've ever used a 110 volt MIG on, you know, just a regular 15 amp breaker in a household current, occasionally you get a nuisance trip. It'll trip the breaker sometimes. I've not had that issue on a 20 amp breaker. So that's what I've been running this on, and so far it's held just fine. They do send you the adapter as well to plug it into a 220 volt service. Hynade said 20 amps. The machine itself, it understands, you know, what you have it plugged into, whether it be 110 volt or 220 volt. The problem is this is not a 20 amp plug. This is known as a industrial round 50 amp plug. You see that's got one prong is larger than the other one, and it's very universal in the welding world as a 50 amp breaker. So since it has a 50 amp plug on it, I decided I'll just put in the matching, rather than trying to make an adapter like a lot of people do to use a 20 or 30 amp at 220. I went ahead and put in the full 50 amp breaker like you'd have for any other, larger 220 volt welder. And I went ahead and put it on a 50 amp breaker. That matches the plug that Hynade sent. I understand it's probably not required, but now I'm set up for any welder I may choose to get in the future. Well, now that we've talked about the electrical requirements for this, I have chosen to run this machine on 220 volt because it should be more efficient. If I get into some thicker materials, it should do a better job on those. So that's what I've opted to do. I did find it's fairly expensive. I was going to put just a single 220 volt outlet about halfway in my shop on one of the walls. I've got a small shop. It's 24 by 32. It gives me enough room to, 2 cars side by side with a little bit of workspace in front of it for, tools and equipment and that type of thing. But anyway, it was going to cost me like $300 to run a 6-gauge wire to put that same plug in the center of one of my walls by the time I run up to the ceiling and then across and then back down to the plug. Even if I did have a plug on one wall, I was still going to have a heavy-duty extension cord in order to use the machine, say here at the workbench or over in the middle of the garage, on a vehicle. So either way, I was going to have to buy a 25-foot extension cord, heavy-duty extension cord. So I opted just to put that electrical plug just right out the bottom of my power panel. It cost me like $50. I ran 3 feet of 6-gauge wire. Is what it took to wire that up. And I did order the 25-foot extension cord, and I can reach virtually anywhere inside the shop or outside the shop from that location in the front corner of my garage, right next to the big garage door. Okay, so moving to the front end of the machine. The only thing that I've really learned so far about it is on these tips. If you saw my first video, you saw the front of the tip, and this is the way it comes with this wire guard on it, and of course the ceramic cup. I don't really understand why they use a ceramic. I'm sure there's a reason. I'm sure it's for heat insulation, that type of thing. I find this little wire guard to be kind of annoying. It kind of gets in my way. You saw one of my cuts I made, it hung up on another cut that I had on the material, and it kind of, it messed me up. I've taken this guard off and used it without the guard. I like it better that way. But then a couple days after I had removed that, I found my ceramic was broken. So if nothing else, this guard does help protect your ceramic from breaking. I put the guard back on this one while I ordered some new cups. The machine does come with the nozzle and this little cap here, whatever you call it. I forget what they're called right now. It does not come with new ceramics. So I ordered another set. I've got like 20 of these ceramics now, along with additional nozzles and these little retainers, whatever you call it. So I've got plenty of spares now. I have heard it said that if you tighten down this ceramic cup on the torch too much, that will cause them to break just from the heat that they will, I want to say shatter, not shatter, but they will crack. And when I had taken this wire off, I did not cinch it down really tight, but I did just put it finger tight, like you just typically feel like you should. And I don't know, maybe that was part of it. Maybe I just, laid it on the ground a little bit too hard. Either way, these ceramic cups are pretty fragile, obviously. It doesn't take much to break them. In my last video, I talked about the consumables that do come with the machine, and here they are. I did mistakenly say there was like, 6 or 8 sets of consumables, including the ceramic. It does not come with the ceramics, the ceramic cup. It does have the nozzles and the tips. It looks like there's a set of 5. So correction on that, that's what it comes with. As I just mentioned, I did break the ceramic cup on the machine. So I ordered this other set of, I think it's 20. you know, nozzles and caps and a whole bunch of those ceramic cups. So if I get careless and break some more of them, which I'm sure will happen, I've got plenty of spares. And this does come with a different type of a guard. So I've not tried this out yet, but you know, this will obviously go on the end of your, in place of this wire guard, you know, this will go on in place and kind of hold you up off your work and you know, give you something to kind of drag with. I find this wired, it kind of got in my way of being able to see what I was doing, in addition to hanging up on the work itself. I don't know if this one will be any better. We'll find out. You know, most of the videos that you watch, people don't use any kind of guard at all. They just drag the tip directly on their work. I find I can see much, much better with no guard at all. The only thing is, you know, breaking the ceramic, obviously. Maybe I'll get better at that. I find I can hold the tip up off the work just slightly, very easily. And I was shocked at how fine of a tip or cut the plasma coming out of the tip. I mean, it's like a pencil. It's just, it's super, super fine. Really impressive. So I'm gonna try this ceramic cup here and make sure my new ones fit. They were supposed to. I ordered them for the AG60P gun, so it should fit. I don't expect it not to. I don't have a reason to change the nozzle and the tip. I've really not used it very much. So, okay, there it is. It fits great. And I'm gonna go just lightly finger tight, and I think I may back it off just a touch, so it's slightly loose. And we'll go with that. Looks like this would take a little pressures to push up on there. I'm almost afraid I'm gonna break that ceramic, you know? It doesn't take much to break. I think I'm gonna try without it, because I'm afraid I'm gonna break one of my brand new cups. Anyway, there you go. Okay, we're gonna do some more test cuts again. And here's what I have planned for today. Here's a piece of 14 gauge. Here's that piece of 1/4 inch powder coated material that we cut off last time. We got some 1/8 inch angle. That was 1.5 inch angle, 1.25 inch angle. And then we got this big piece of 3 inch square. It's about 3/8 wall, looks like, something like that. And we're gonna cut those on the 220 volt, and we'll see how it goes. I just got the machine set in the floor right now rather than sticking it back in the cart. One thing I did make a mistake on, I misspoke in the last video, was the length of the torch and the ground cables. I had said 12 meters. I meant 4 meters, about 12 feet was the length of the torch. The grounding clamp looks to be about 10 feet, and torch is about 12 feet. So, sorry for that. And I do have it hooked up to my 25-foot extension cord, back over to my plug-in there underneath my breaker box. So it reaches back here to the back of the garage at the bench, really easy. Before we get too far ahead, this is the settings guide that came with the machine. Obviously I converted from millimeters to inches. There where you can see I've written in. I don't think in millimeters myself, you know. Inches is where my mind is, so this is the guide. I need to, you know, copy this chart and laminate it or something, because this is just, you know, in the instruction booklet, and this is not going to last very long here around the shop, even if I do try to take care of it. So that's the guide on my settings as far as amps and air pressure. Okay, I've got the machine set up according to the chart on 20 amps and about 50 psi for the thinner stuff. That'll be the 14 gauge and the 1/8 inch. So we'll see how that goes. Again, I'm just using my welding helmet. One of the comments on the first video recommended going to Home Depot and buying just some flip down shades and about a number 5 tint as recommended. And one guy said that worked really well for him. I've not gotten by there yet to take a look at that, so that's on my list of things to do. In the meantime, I'll use what I've got. Okay, here we go, 14 gauge material. Get it off nice and clean. I am set up on 220 volt, by the way, if I had to not mention that. And made a pretty nice cut there. A little bit of slag on the back, but from what I understand, that slag just breaks off with a chipping hammer for the most part. It doesn't take a whole lot of cleanup. Okay, moving on to the 1/8 inch angle here. If I've not I don't think I've mentioned it yet. Why do you want a plasma arc? I mean, a pilot arc, as opposed to just a standard lower cost plasma cutter without the pilot arc function? The pilot arc allows you to do this. It's kind of cool. The real reason for it is a normal plasma cutter without the pilot arc function. You have to have clean metal to get the arc started. It's kind of like welding. If you don't have good clean metal to start the arc, then it can't start the arc. The pilot arc starts that arc for you, so you can cut on coated, rusty, old material. You don't have to have brand new steel. You don't have to grind a clean spot, so that you can get started with your cutting. So that's the reason I was looking specifically for a pilot arc machine and a low cost Amazon type of a product. Okay, 1/8 inch steel, same settings. You know what? I'm going to try the straight edge thing again. See if I can mess that up a second time. I'll just use another piece of steel as a straight edge. I have to say I couldn't see what I was doing. I guess my material's a little bit too thick. We'll go back to freehand. Okay, apparently I did get good on that first cut. I just couldn't see what I was doing. There is a fine art to your travel speed. And as one person pointed out on my first video, the plasma cutter is not a hammer. You know how you emulate what you've seen done before. All the videos that I've watched, you know, everybody taps that last little bit with the nozzle itself. I agree, it's not a good idea, especially as easy as these ceramic tips are to break. Hit it with something else other than your plasma. Okay, we're going to step on up to the 1/4 inch plated, powder cover material. See if we can get the travel speed right this time. I had a little trouble with this one on my first video. With my travel speed was the biggest issue. It took me like 3 times to kind of get it right. Should go better this time. Let's see, look at my chart. We stepped up to 1/4 inch material. That's still pretty close. I'm gonna leave the settings the same. So on 220 volt, I'm at 30 amps and about 50 PSI. When we go to the 3/8 material, we're gonna change the settings just a little bit. Cut on a little bit, but still cut pretty good. Again, travel speed has a lot to do with it. I feel like I could have gone up on the amperage just a little bit there. Where am I set right now? Yeah. Actually, I've got my settings a little bit too low. I'm at 20 amps right now, and according to the chart for 1/4 inch, I should have been at 30 amps and 50 PSI. I'm gonna crank it up to 30 amps and see how much different that makes. Okay, 30 amps, 50 PSI. Much better. Having the right setting has everything to do with it. Okay, let's step up to the big boys, see if we can cut an end off of this thing. 3/8 thick material. This machine is supposed to clean cut 3/8 material. We'll see. I did play with it a little bit last week and just kind of freehand gouged it a little bit to see, and it did cut through. Left quite a bit of slag on the inside, but let's see if we can do a better job today. According to the chart, 3/8 material, I need to step up to about 40 amps and 60 PSI. When you do set up your machine, your air pressure, you do need to pull the trigger and see where the gauge goes to. Make sure you're still at 60 PSI while you're setting. And I'm pretty close. Okay, here we go, 3/8 material. I have to say there, on my horizontal cut, I could see with my number 9 shield, but on the vertical cut, coming up the front side, I couldn't see what I was doing. It's dark. I couldn't see much. So it's really ugly on the front side there. Roll it on around, see if we can cut it all the way off. I'm gonna make all my cuts horizontal where I can kind of see what's going on. Right now what I'm doing is kind of holding the tip up off of the material a little bit, because the material is so thick this way, from my point of view, I can't see the sparks blowing out the other side. So I can, by holding the tip up off the edge a little bit, I can kind of see the cut line where the plasma is actually hitting the material, and it helps me out kind of stay where I want to be. I'm having a really hard time seeing. This number 9 may be too dark. Okay, I had a hard time getting through it this time. I'm going to crank up the amperage. I'm going up to the full 50 amps. The top of this chart is 50 amps and 70 PSI. We're just going to go there and see if that helps. Okay, 50 amps, 70 PSI on 220 volt. Just having a hard time cutting through that right now. I don't know if my tips and my nozzle are being fouled or what, but it's not doing too well right now. I'm letting the compressor catch up and we'll start fresh. Some of you guys are probably laughing at me right now. I found out what I was doing. I hope to show you guys my mistakes so maybe you can learn as well. You know, I am new to this. We all make mistakes. Not everything you see on YouTube shows you know, everything going perfectly as planned. It doesn't always happen that way in real life. Ground clamp is real important when you're trying to cut with a plasma cutter. So essentially, what I was trying to do was cut with just the pilot arc alone, and that's not going to cut it, especially on 3/8 inch material. Let's hook the ground clamp up again and see what difference that makes. I bet that'll fix the problem. Also, back to the ceramic tip thing, the ceramic cup. I just checked the tightness on this now that I've used it a little bit and it's got a little bit of heat in it. And as loose as I had left this ceramic, it still had a little bit of a bite. It took a little bit to crack it loose. So be careful of that. You know, leave your ceramic loose and maybe they'll save you some of your consumables. Okay, now that we're hooked up, we're still maxed out at 50 amps, 70 PSI. I bet it cuts better this time. Oh yeah, no issue. Put a glove on, it's trying to get a little heat in that material. Ground clamp. Got my corners loose here and it should fall off. Ground clamp. Like one more corner here. You should be close enough to at least hammer it off. Yep. Yeah, it's really close. It's ready to fall off there with a little bit of a collision. Understand 3/8 is kind of the upper limit for this machine. I think it said it would cut through 1/2 inch, but not cleanly. It claimed 3/8 of an inch clean cut. We'll find out here. As bad of a cutter as I am, not terrible, considering. Okay, so what did we learn today? We learned a ground clamp is really important. You have to ground your material or it won't cut worth squat. What else did we learn? Air pressure is important. Travel speed is important. Be careful with your ceramic cups on how tight they are. Maybe that'll save you from cracking a few and having to replace them. Overall, for $199, I'm pleased with it. It's going to do everything I need to do with it. Truth be told, I do have a bandsaw here that is what I will use the biggest part of the time, you know, for most material. If it's going to fit in the bandsaw, let's see, there's my bandsaw. Then the bandsaw is what I'm going to use. It's going to make the fastest, cleanest cut for my purposes. You know, most things I do, I want a nice clean cut. I don't like to have to get out the grinder and clean up the edge. But there are times where the plasma cutter would be really nice. You know, thicker material, making odd cuts, something that won't fit in the bandsaw, obviously. I'm gonna use the plasma for that. Maybe I need to cut, you know, brackets off of a frame. I've seen people use the plasma cutter to cut off rusty bolts and nuts. Things like that is really the reason I bought it and my intended purpose for it. So that's the plan. Okay, now let me show you some of my projects. This is my 1966 Chevy C10. This is one of those long-term projects I started many years ago. Looking back through the forums, I started posting on the 67 through 72 Chevy truck forums. I started posting this truck in 2007. So it's 2022 right now, so somewhere in the ballpark of 15 years ago is when I started building this truck. We've gone through all the rust repair on it. You can tell it's been lengthened. And it's got a few extra components in the back end. So maybe I can finish this thing this year. It's always at the bottom of my list. You know what I mean? Everybody has project lists. Then you have lists that your wife gives you on top of that, and your kids. And you know, never seems to be time or money left over for the stuff that you'd really like to do. This is the project that's always been at the bottom of my list. I've put rocker panels, cab corners, half the floorboard on both sides. I don't think there's a panel on the truck that I've not had to you know, make a patch for, or done some welding, or modified it. It was originally a short bed, step side obviously, two-wheel drive truck. Now it's four-wheel drive, but it has 6 wheels. There are 2 9-inch forward axles in the back end, and they're driven by a divorce-mounted NP205 gear-driven transfer case. Being a divorce-mounted case, it has 3 yokes on it for drive shafts. You have 3 drive shafts. I turn that transfer case around backwards, so I feed into what is normally the rear output on the transfer case. So I go from motor to transmission to the transfer case, and that gives me 2 drive lines to each of the rear axles. I stretched the frame 34 inches. Those are the original fenders. I cut them in half and put 34 inches in the middle of them. So they're all steel. I built the rest of the bed myself. I used the original stake pockets, bent new bed sides obviously. Used 14 gauge sheet in the bottom of the bed. We'll just do a walk around. See, let's see a little closer. Okay, 66 Chevy truck. Let's talk about the back end. That's the most unique part about this truck. Those are the original fenders. I cut them in half right between the wheels and made a panel. Well, I had a shop downtown bend me a panel. I took them half of a fender and told them I needed a panel 34 inches long that would match this contour. And they did a really nice job bending the panel for me. So it's welded. Let's see, right there's the seam, and right there's the seam. So that's how long the panel is. They put in the middle of those fenders to stretch them. The bed sides, the same company bent new sheet metal for me. It's 18 gauge sheet metal. They essentially just, you know, put the 90-degree bend on it. They did not have a way to roll the edge, so I took a piece of thin wall tubing and welded down the edge to get the roll to give it the factory look. These are the original stake pockets off the original bed. I just cut them off the original bed and grafted them into the new sheet metal. Of course, just built a new front of the bed, just a piece of square tubing, another piece of sheet. It's got 14 gauge solid sheet in the bed. I intend to just bed line the inside of this bed because I want to be able to use it. You know, it's a truck. I'm not going to haul motorcycles or engines in it, but if I want to throw trash or a cooler or something in the back of it, luggage, you know, go on a trip, I'm going to throw it in the bed of the truck. Back end, new tailgate. Obviously, you know, it is what it is. Pair of 9-inch forward axles. I'll see if I can get underneath the truck here in a minute. It is on airbags, so the suspension is completely drooped out right now. That's as far down as airbags and the shocks will let it go. When this truck is sitting on the floor, it's on jack stands right now. when it's on the floor, the frame lays about 1 inch off the floor, so it'll still roll, but it doesn't steer too good because those tires tuck up inside the front fenders so far. Like I said before, I've put bottoms in the doors, I've put rocker panels, cab corners, half the floorboard on both sides. And the transmission tunnel has been raised 5 inches, I believe it was. I can't remember. And I'll show you that why here in a second. Obviously, I've still got a lot of work to do here on the inside. I'm going to change the steering column to something a little nicer. I decided to go with a floor shift directly out of the 350 turbo. And I don't need the column shifter anymore. So rather than just removing the pin and leaving it, I'm probably just going to change the whole column. Got to work on the brake pedal a little bit. The pedal itself is kind of at the wrong angle. It feels funny. So we're going to do some work there. The truck does have 6-wheel disc brakes. The way it is hooked up right now, well, let me back up. I moved to a new house about 1.5 years ago. So the summer of, what would that have been, 2019, I was in a mad rush to try to get this truck running and moving under its own power. I was bound and determined to drive it onto a trailer in order to bring it to the new house and drive it back off. One of the big things that stopped me was the gas pedal. You can't drive a truck without a gas pedal. The gas pedal that's in this truck now is just one of the low-cost pieces I got from Amazon. It's cable operated through the underside of the floor up to the carburetors. And the cable that they sent with the thing ended up not having any liner inside of it. So the first time I pushed down the gas pedal, it wouldn't come back up. It just the sheathing collapsed. So there's no way it would work. You can see down in there maybe where I tried to put zip ties on a piece of tubing along it to try to hold the sheathing flat enough and straight enough that maybe it would work to drive the thing on the trailer. And it didn't work. It's just really cheap. It's hard to see there. I don't know if I can zoom in. You can see how the sheathing just collapsed on the thing. So it needs a new throttle cable. And long story short, I ran out of time to be able to get the thing driving, at least moving under its own power. As far as suspension and frame goes, I sunk the frame rails 5 inches down into the crossmember. Basically, I boxed the frame. I ended up having to take 1.5 inches out of the bottom of the frame, and then the other 2.5, 3 inches, whatever's left, out of, that's the depth that I had in the crossmember itself. So the frame rails now sit down inside of a slot in the crossmember, and then it's all welded together. Originally, this crossmember sat underneath the original C-channel frame. So the reason I did that is it's cheap. It didn't cost me any money. It was cutting and welding. I built the brackets, for the upper control arm, because obviously those used to bolt into the side of the stock frame. Now they're above the stock frame. All the suspension is all stock components. It does have a bolt-in airbag, just off-the-shelf bolt-in brackets for a C10. The spindles, the control arms are all factory. They're not drop spindles or anything. I did use a rack and pinion steering out of a mid-90s Camaro Z28, just to try to clean up the steering a little bit. And we'll see how that works. It should work just fine. You can see I had to notch the frame to get it at the proper angles, the height and the angles that I wanted. But that's out in front of the suspension, so I built those strong back brackets to kind of strengthen the front frame horns a little bit better. And so far it seems to work okay. I would not recommend jacking up the truck, by the radiator support and jack it up by the crossmember underneath the motor, like you normally would these old trucks. Anyway, that's it. Motor is a 350 4-bolt main. I built this motor actually for a Jaguar that I built years ago. So the motor itself's probably got 10,000 miles on it, something like that. It's just it's a stock 350. It's got flat top pistons in it. I believe this one's standard bore. It's so long ago. It's 20 years ago I built this motor. I did go back and change when I put the motor in this truck. I changed the cam. It's got a Edelbrock Performer RPM cam in it. Obviously, I went to a 3-deuce intake. And It's kind of seemed to fit the era of this truck. And with the motor and everything being raised, because the crossmember weight was raised on the frame, that's the reason the tunnel on the inside of the truck has been raised. I wanted to go ahead and, if you're going to have 3 deuces, you might as well show them off, because I wanted them to sit, kind of through the hood, just enough to kind of give it a hint of what's under there. So that's the reason they sit that way. Little something extra for people to look at. Okay, don't know if I can get underneath the truck very well with the camera and lighting, but I'll try to show you what's underneath. Okay, I told you it's going to be interesting trying to show you this underneath this truck with it sitting on jack stands. I don't have the luxury of a lift, although it's on my list. This is, let's see, right there's transmission, drive shaft going between the air tanks, going to the divorced NP205 transfer case. You can see the single input there. So you put the transfer case in 4 high, and obviously all 3 yokes spin at the same speed. So it works just fine that way. It is a cast iron, gear-driven case. They're considered bulletproof. That's what all the off-road guys really would like to use as far as strength goes. There is no factory transfer case that was stronger, at least in the 1-ton and down trucks. Okay, now you can see the 2 drive shafts leaving the transfer case. Maybe trying to roll around here and give you a view. Sorry about the video, folks. I'm laying on the floor here doing the best I can. So it feeds the front axle, and it also feeds a carrier bearing that feeds on to the rear axle. Now the second axle is offset to the passenger side in order to line up with the secondary output on the transfer case. And you may wonder about the driveline angles. The pinion angles are set the same as the output angles from the transfer case. So in theory, the angles are equal and opposite, therefore they cancel one another. Now remember, this truck is sitting with the suspension at full droop. So this suspension is lower than what it will be at ride height. It won't be this high riding down the road. So angles won't be this severe. They'll be much more level than what they are right now. You can see the link set up on the axles. I built a 3-link with a triangulated upper wishbone for this truck. Used polyurethane bushings at all of the ends. The upper wishbone has a threaded bushing in it for adjustment of a pinion angle if I ever needed adjustment. The 3-link is parallel, so throughout the entire suspension travel up and down, the pinion angle stays the same. I measured it at longer travel than what the airbags will allow, and the pinion angle stayed within half a degree from completely bottomed out to completely drooped. More range than what suspension will actually allow. Like I said, there are 6 airbags in this truck, 1 on each axle, and obviously the 2 in the front. And it does have 6-wheel disc brakes, which I'm trying to work out right now. This truck does have the proper C10 two-wheel drive wheel bolt pattern, which is a 5-on-5. That's the pattern Chevy used when they went to disc brakes in the early 70s. 72 maybe was the first year of disc brakes. Anyway, in order to keep that proper bolt pattern, these wheels, or these the rotors that I found, it's off of an all-wheel drive Astrovan. Happens to have the same 5-on-5 bolt pattern. And I just used normal C10 calipers and with some weld-on brackets in order to make the disc brake kits for the rear axles. The second axle, with it being with the housing being offset to the passenger side, it has Dutchman chromoly axle shafts in it. Chromoly because that's the only blanks that Dutchman had that was long enough to make the long side that I needed for this axle. To be honest, I didn't realize that I was going to be limited on how long the axle could be. So that was kind of a trial and error, but it worked out. I had to rework the offset on the axle a little bit, get the axle tubes and weld them back together in order to accommodate the axle shafts that I could get, but it all works out. The rear 9-inch is actually out of an 84 Ford van, half-ton van. The front one is out of a 65 Ford Galaxy. Obviously, I had to do some cutting on the van axle in order to get it to match the Galaxy axle, the width and all, but it all works out. You know, it's all 9-inch Ford. It's all pretty much universal. Then on the back end of the truck, obviously there's a fuel cell. And then you can see the offset axles and the suspension a little bit better, maybe, possibly. Anyway, that's what makes this truck tick. Okay, so after we get the gas pedal hooked up, brakes worked out, transmission dipstick, next thing we need is wiring. Because it's essentially got brakes, although it needs a little bit of work. The fuel system's already in, the fuel cell is in, the fuel pump is in, the fuel line all the way up to the front. I got to finish hooking them to the carburetors like we just spoke about. So that's the fuel system. The cooling system is in it. It's already full. The motor has oil in it. Transmission has fluid in it. Although it's been sitting for 2 years since I pumped up the oil pressure in the motor. So we'll be pulling the distributor back out and run up the oil pressure again before we start this motor. We don't want to run it dry and wipe out the bearings. So really wiring would be the next thing after getting those few, brakes and transmission and accelerator pedal. We need wiring. Run a few wires. Might as well go, the truck needs wires anyway. It has no wires at all in it right now. So we need to get a wiring set up or on order to get in the truck and start wiring the thing, and it should fire up and move under its own power pretty easily. So that's on the agenda for here in the next couple of months, next month or so, next few weeks. Goal is to at least get the thing moving under its own power this spring. You can tell the hood is a slightly different color. I had painted this truck one time with a single stage acrylic urethane from Summit Racing, and it did okay. It did fine. Had a little bit of streaking in it, which drove me nuts. I painted the hood a second time, and it still had a few streaks in it. None of the rest of the truck streaked at all. But I'm finding out I'm not the best body man for sure. I'm definitely not the best painter, but the pearl that was in the paint is really what gave me the biggest issue. I've shot metallics before. I've never had streaking, ever, anytime I've shot a truck, until this truck. I think the pearl is the problem. When I redid the bodywork on the trucks, I wasn't happy with the bodywork on the back of the cab, and the doors were wavy, and I just wasn't happy with it. I bought a set of Dura blocks to see if I could do a little bit better bodywork on the truck, and repainted the rest of the truck, and ran out of paint. I strategically, painted certain panels to make sure I had enough to finish what I was painting. So if I ran out, I wouldn't be, short on the entire truck. I'd be short on a hood, for instance. I'm a little bit short on the paint, so the hood needs to be painted to match the truck. Let's see, I painted this probably 4 years ago, to be honest. The new color of blue that's on the rest of the truck. So who knows if it'll match anyway. Anyway, the goal is I want to make sure that 3-deuce setup works. There's a hole in the hood. If I have issues with that 3-deuce, the easy thing is to go back to just a single four-barrel carburetor. The hole in the hood, would be out of place at that point. So let's get the thing moving and running under its own power first, and then we'll decide what to do with the hood. Either swap it out because of a carburetor change, or paint it and see if it'll match. The doors are still not as straight as I would like them to be. Again, I'm not a good body man. I don't have the patience for it. I kind of know the general idea of how to do it, but I just don't have the patience for it. So then I wrestle with myself. Do I want to delay it, another couple of years and rework the doors again to paint them again? Or you know what? The rat rod rough look is in right now. Go with it. Get it out and enjoy it. The truck's been sitting for 15 years. And honestly, the reason is the body work. I don't mind the mechanical, the metal work. I don't like body work. So that's the reason it's been so long. But I need to get this truck out and enjoy it. After we get it running and driving, it needs glass and rubber, and bumpers and lights, and that's essentially it. It's ready to tag it, shoot some bed liner. I'm going to bed liner the floor on the inside, and of course inside the bed itself, and may change the seats at some point, but for now I think I'm going to pull the headrest off the seats that are in there. I need to build some supports to get them up off the floor a little bit, And so that's coming up. I'm going to try to video it, and hopefully you guys will follow along. See ya.